Thanks for joining me. My name is Richie King, and I'm a visual journalist at 538. So how many of you guys have heard of 538? OK, so like about half of you. So 538 is a relatively new, about a year old, data journalism website that was started by Nate Silver, who's a statistician who does a lot of predictive analysis for elections, for big sporting events. And he used to run a blog called 538 at the New York Times. And he correctly predicted the electoral outcome of every state in the presidential election in 2012 and kind of garnered a little bit of fame after that. And then he left the New York Times, started his own website under ESPN. And that's where I work now. And there are like about 25 of us on the editorial staff there. And so what I do is I call myself a visual journalist for lack of a better term, but basically what that means is that I'm a reporter like all the other reporters in the newsroom. I do research, I interview people, and then we'll produce a story. And but the key difference is that when I produce a story, it's more often than not a story that is told through data and data visualization as opposed to like words. So that's basically what I do. Oh, I also I wrote a introductory textbook on D3 called Visual Storytelling with D3, which is also the name of this talk, I think. Yeah, so that's me. I'll just get right into this this D3 thing. So how many of you guys have used D3 before? OK, cool, fair number. And how many of you are JavaScript programmers? OK, slightly more. OK, great, cool. So a fair number of you didn't raise your hand, which is great, because this is a pretty, in some ways, introductory level talk. But I sort of want to go through what D3 is and what makes it so powerful, kind of on a conceptual level. So hopefully that will still be interesting for people who've used D3 before. I think it should be. But I just wanted to sort of super quickly show you all some of the projects that I've built using D3. So I use D3 all the time. This is 538's Senate forecast for these past midterm elections, and so I sort of used D3 to make this histogram. So like Nate did this analysis where we ran all these simulations, and this is sort of a histogram of the results, the breakdown of seats in the Senate between Republicans and Democrats. So use D3 to like build this histogram, build this like table chart with all these interactions, make these maps. We also built an interactive around the World Cup, sort of showing our predictions that we use D3 for. And then we recently launched this interactive where you can look up any flight in the US and see like how delayed it typically is. So use D3 to basically do almost everything here. A little bit of backbone in the mix as well. But it's super powerful, and like you can use D3 to make like, any kind of chart or map you can dream of, basically. Like it's sort of unlimited in what it can do as far as like just visualizing data goes. And the reason for that, which I'm going to skip over these other examples for right now anyway. So the reason for that is that like D3 is not a charting library, which might be a little surprising, because if you know anything about it, you probably know that it's like a JavaScript library that's used to make charts and data visualizations. But at its core, it's not a charting library. And what I mean by that is that if you look at something that truly is a charting library, like ggplot. So people here use ggplot before? Any R users? A few? So ggplot is a charting library in our charting package. And if you want to make a really basic line chart in ggplot, this is what your code looks like. You define a data frame. You have some x values, some y values. And then you use, it's getting a little cut off on the edge there. You use this function called qplot. You pass those values in, and you specify what's called a geometry, in this case a line. You want to make a line chart. You say you want to make a line chart. and then this is what it spits out. So like 2 lines of code, you got a line chart. If D3 were a charting library, it would be, it might look something like this. Like it'd be really similar. You define your input values, an array of x and y values, and then you have this like function called chart or something, and you pass those values in. You specify the type of chart that you want, the line chart, and since it's JavaScript and you're dealing with a browser, maybe you add some dimensions to define the size. But in reality, what D3 actually looks like if you want to make a simple line chart is this, which is, I don't even know, have like a couple dozen lines of code, and which like is a ton of work to go through to make like the most basic chart form for a data set of 4 points, right? So this is why I say like D3 is not a charting library, because it's not built to just like produce charts. And the reason for that is that like I think with pretty much all software and programming languages or libraries or packages, like there's always sort of this trade-off between something that's easy to use and something that's super powerful and flexible. And the thing is, like with a lot of honest-to-God charting libraries, they are easy to use because they've made a lot of decisions for you, and that can be really nice and convenient. But if you want to be able to have a ton of control, like you don't want the library to have made those decisions for you. You want to be able to make them yourself. So on this spectrum from easy to use to powerful and flexible, D3 is like sort of way on the extreme side on the powerful and flexible side. And so what D3 actually is sort of communicated by its name, although that's a little inscrutable. So data-driven documents. The documents in this case refer to web documents, so basically like web pages. The data-driven bit means that like you can totally sculpt and shape those web pages based on data. So I'm going to talk a little bit about the document object model, which is kind of like the sort of the hierarchy that underlies web pages. So web pages are sort of organized into this like hierarchical tree structure, and it's called the DOM tree, document object model. And so this is the thing that you're manipulating with D3 using data. So I'll show you what I mean. Can't really see that. So say you have a web page that looks like this. Like it's basically just, you just have like an H1 at the top, the headline, and then a paragraph right below it. This is what the underlying HTML would look like. An HTML tag. Inside of that, you have a head and a body. Inside of the body, you have the H1. Inside of that, you could have a div, and then a paragraph inside of that div. And this is a sort of graphical representation of what the DOM tree looks like in this case, which I think is pretty self-explanatory. So D3 lets you like sort of manipulate this DOM tree directly with data. So say we want to, wait till I have this, right. So say we want to make a web page that looks like this using D3, like just 5 separate paragraphs, and each one reads, like paragraph 1, paragraph 2, et cetera. What we could do is start with an array of data. So each of those strings that we have as like an entry in this array. And then with D3, you can take that array and join it up with the web page using this thing called a data join, and then make the web page look like the data. So start with like basically a blank page. This is what the DOM tree looks like. Just have an HTML object with a head and a body. And to carry out a data join, what you do is you select a node in this tree that you want to join your data up with. In this case, we're going to join it up with the body. And then you take your data and you carry out the data join And what it does is like you grab the body and you're like, okay, here's my data array. It's these 5 strings. And then using D3, you say, okay, like I want to attach like a placeholder node for every single one of the objects in my data array. Does that make sense? So like we have these 5 strings. I want 5 placeholder nodes. And then you say, okay, what I want those nodes to be are paragraphs. Make each one of them a paragraph element. And then the really nice thing that D3 does is it creates a new node that you can specify for every single object in your data array. And then it binds the data to that node, and you can tell the web page what you want inside of that node based on what's in that data. So we're saying, create new objects, create a new node, make them paragraphs, and then make what's inside those paragraphs equal to the string that's in the data array. Okay, so this is what the code looks like in D3 to do that. So I'll go through this kind of like step by step with the diagrams that I just showed. So the first thing is selecting a node in that DOM tree. So in our case, you select the body, and you do it using this method called select. So we've selected the body. Then you sort of do this weird thing where after you've selected the body, you select all of the paragraph elements that are like the children of that body element. But initially, like there aren't any. Like before you've actually done the data join, when you do that select all p, like you're not really selecting anything. There's nothing there. But you're just sort of setting the stage for D3 to tell the DOM to create a bunch of nodes as children of this body. So the way you do that is by calling this .data method. So you do .data, pass in our data object, and then it creates a new node that's a child of body for each entry in that data array. All right, so then the next step is actually selecting all of those new nodes and then turning them into paragraphs. So that's what we do with this next line here. This like .enter .append. Okay, and then the next step is like setting the text of each of those paragraphs based on the data that you've bound to them. So that's what this like .text method does, and this function that you pass in is just what grabs the data. So I'm not gonna focus on the code like too much. I kind of just want to sort of cover it more conceptually. So okay, cool. So that's all well and good. That's just how D3 creates new things on a web page. But what if you want to update something that's already on a web page? So like that's super easy too, and it works pretty much the same way. So say we have a new data array, and very similar but different strings, and we want to update the paragraphs on our page to show these new strings. You basically do the same thing. You do another data join, and you can just swap the text right out. And so the code looks like almost identical. The only difference is we don't use that .enter .append thing because those elements are already there. So we just grab them, we bind the new data, and then we change the text to the text in our new data. So then here's like similar third case where you're binding new data, but there are fewer entries in this array than there are elements on the page. So like what happens there? Like so you're joining this new data up with what's on your page, and it's pretty easy to just like you can just swap out the text in the top 3 things. But what would also be nice is to have a way of getting rid of those elements for which there is no new data. So D3 makes that really, really easy too, and it does that through this .exit method, which basically like it does just that. It just selects the elements for which there was no new data point. And then you can use this .remove method to just like get rid of them. Is this all making sense? Yeah? Okay. So here's just like a really, so this notion of a data join in D3 has these sort of like, what I like to think of as like 3 phases. And they, on a fundamental level, they sort of make a lot of sense, right? It's like you're looking at a web page and you want to be able to create, manipulate, and remove objects from that web page. So, you know, those are the only 3 things you can do. You can like create new things, you can update things that are already there, or you can get rid of things. In D3, those 3 phases are sort of like referred to as enter, update, and exit. And when you conduct a data join, like which of those 3 things you're dealing with it's really just an issue of counting. It's totally just an issue of counting. So if you have more data points than elements, then you're sort of like you're in like the enter phase. If you have an element for every data point, then you're like updating. And if you have fewer data points than elements, then you're sort of in the exit phase. Okay, so let's see, actually I'm going to pop back over. Oh, that's weird. Oh, there we go. Okay. So this is just like so this is something that Mike Bostock, the guy who wrote D3, made as just sort of like an illustration of these 3 things of enter, update, and exit. And so what's happening here is he just has a loop that's generating a random array of letters. And then you know, every time a new array is generated, conducts a data join with what's already on the page. And then you know, if there are new letters, then they enter the page and you see them coming down in green. If there are like letters that are exiting, you know, like they turn red and slide off. And then the letters that are updating just get adjusted so that the letters are always in alphabetical order. Okay, so this is like, you know, I don't know, like it's kind of a cool concept, but it's maybe not super clear like how you use this concept to make like maps and like network diagrams and bar charts. But there are kind of two other things that I'm going to go over that will sort of bridge that gap. So those 2 things are SVG, scalable vector graphics, and scales in D3. So are you guys familiar with SVG? Yeah? Okay, cool. I'm not going to spend too much time on SVG, but suffice it to say, it's you know, it's works very much like HTML, except instead of like textual objects, you actually have shapes and geometric objects. So you know, you can use D3 to manipulate the DOM tree in cases where you have a DOM tree that actually has like shapes instead of words. So that's one reason why it's, you know, it's useful to like why you can use D3 to make charts. Just show you this really like basic bar chart. So I made this for the textbook that I wrote. Kind of walks through how to build this like really basic interactive bar chart as a way of teaching D3. But basically, you know, it's this same sort of idea where you have a. So this is what the DOM looks like when you first load up that chart. So like you have this SVG element, and then you have all these rectangles, and I've given them, you know, so they have widths that are proportional to the data that they're representing. When you, so this is kind of an abbreviated version of what the DOM tree looks like there. And when the page is first loading, you know, it's connecting these data points. So actually, let me go back to this chart. Oops. So I might have breezed over this too quickly, but what this chart is showing is the age distribution of the world. So like what percent of the population is 80 and older, between 75 and 79, et cetera. When it first loads, it defaults to 2010. And so I'm actually taking the 2010 data, doing a data join, and creating rectangles that weren't already there. And then subsequently, whenever somebody clicks on a year, like 1950, I'm doing another data join, taking the 1950 data, and then joining it up with those same rectangles. And then it's actually like super easy to make the rectangles move. It's really just this one line. You can just do this like dot transition, and then when you update the data based on a year that the users clicked, like the rectangles will just automatically like slide into their new positions, which is super nice. Okay, cool. So I'll talk a little bit about scales. So basically what scales do in D3 is so this is that bar chart, and you'll notice like each of the bars is set to this like weird, like super weirdly precise width. Also like those widths, they don't equal the data points themselves. Like, I mean, this 80 and up is like 0.02 or something, but the width shown here is like 31, 32. And so that's where scales come into play in D3. Like, and what scales basically do is you can use scales to create these functions that take your data points and then just like map them onto the sort of the pixel space that you're looking at. So the most basic scale in D3 is just like just a straight up linear scale. And the way it works is you enter a domain. So in our case, like for this bar chart, I think the highest value is actually maybe around 15%. And then, so that's your input, the input domain. And then what it outputs is like the values that you specify for a range. So basically, what you would be doing with this is you input a value, say like 0.05 or something. And then it just, it's just like a linear scale. So like if you input 0, you get out 0. If you input 0.15, you get out 400. And 0.075, you get out 200. And so that's how you just map the data points to pixels. So this is like the most basic example of that, but that is like every time you look at something that's been made with D3, that's like what's going on is somebody's using data joins to create things, modify things, and remove things, and somebody's using a scale to map the data onto like the pixel space in the browser. And that's basically it. And like, beyond that, D3 there aren't really any hard constraints. So that's what really makes it so powerful. So let's see. How much time do we have? 3:15. So here's the thing that Mike Bostic, the guy who created D3, made. This is just it's just sort of a remix of the Gapminder, World and Health of Nations scatter plot. But you can see like it just sort of like he's using a data join to create all these little dots, one for each country, and every time you sort of scroll over these years, they change position. And again, he's using a data join, and then just using a scale to take the data input and transfer it into a position and a size for each of these circles. But So D3 is great at, so like you can do that to make like really basic chart forms, but you can also make like these weird collapsible node diagrams. And there are all these functions for like creating this realistic looking sort of like physics as you drag the thing around. You can visualize like weird algorithms like this. This is a kind of a, if you're able to hear this. But you can like, whatever, you can bind really ugly sounding noises if you want to objects and then make them play those sounds. You can make super crazy looking projections for maps. This was made by this guy, Jason Davies, who contributes a lot to D3, particularly like its geographical stuff. This is another thing he made that I love. It's like every dot is an airport. It's every airport in the world, and there's this sort of Voronoi layer over top. So any point on the Earth you can see, like any point inside this shape is closer to this Lihu airport than any other airport in the world. And so you can kind of see like which airports are the most remote by just looking at the area of this Voronoi cell. You can also like make crazy fractal things. I don't know. Yeah, it just really like actually that does end. But yeah, so there's this whole like, if you go to d3js.org and click on examples there, I mean, really, it's like anything you could imagine is up here. Like word clouds, like I don't know, parallel coordinate charts. There's really just like, yeah, it's just kind of endless. So, I wasn't sure if we're going to have time, but there was like another. I was thinking about showing an example of nesting, but I'd also be happy to just take questions. But I'll show you. Oh yeah, I should probably also mention some like. So this is just a super basic small multiples graph that I made. Sorry, I'm just trying to show you that all these charts are in like their own separate divs, which I kind of like because it's just sort of seamlessly responsive. Sorry, I'm kind of rambling a little bit. I'm going to show you guys some like resources for getting started with D3, and then if you're interested, I can sort of show you. There's kind of an interesting like data nesting thing that I did to structure the data in a way that like makes producing a bunch of charts like this super easy. So I'd be happy to show you that trick, or happy to like talk about other things. But first, I'll show you just some really super useful D3 resources. So probably the most useful is like these things called blocks. So Mike Bostock wrote this thing called blocks, which takes GitHub gists and like sort of converts them into these web pages that sort of show the output of whatever it is you've built in D3 at the top, and shows some text that you've written in README, and then shows your code. So he's like, let me just pull up his page. I mean, I don't know how many of these things he's made, like hundreds and hundreds. And basically anything that you want to do in D3, Mike Bostock has probably done and turned into a block. So you can look at his code and get an idea of how to do it. And there's even like Block Explorer. There's even this really sweet tool called Block Explorer, which, if you're like confused about how to use a function or method in D3, you can just type it in and it will pull up all of the blocks that use that function or method. And then so you can just like see how it's used. So like all the code is down here. So blocks are super, super helpful. I think that there's a risk though. I know that when I started using D3, there was like a really long period where it's like the code examples are so good that you can almost do anything you want by just like cutting and pasting and sort of like patching them together. But it's really easy to, at a certain point, like you'll probably want to do something that hasn't quite been done in one of these blocks. And if you don't really like understand the D3 fundamentals, then it's really hard to make that jump. So I would definitely recommend, if you want to like get into using D3, I would definitely recommend getting like an intro textbook or going through some tutorials and actually trying to understand how it works and sort of avoiding the trap of just cutting and pasting the work that exists. So yeah, do you guys want to see the nesting trick, or do you want to just ask questions about D3 or nesting trick? Okay, all right. Let's do the nesting trick. So I should apologize. This is like the first talk that I've given, and I kind of had no idea how to like structure the timing, and I wasn't sure how fast this was going to move. So it ended up moving a lot faster than I thought. But I can show you this nesting trick. So let's see. Okay. So in this little small multiple line chart, like each little block is a different low-income country, and what we're showing is their income per capita over time. So if you think about like what I was talking earlier about how D3 lets you manipulate the DOM based directly on data, and how it sort of creates a new element for each entry in your data array. The way that you have to structure the data behind these charts to make that work is like you have to have a nested array where at the top level, every entry is just a country. And then inside of that, there is all of the data points. So then you can use like a sort of secondary data join to create each of the lines. So like you do one data join on a top level to create each of the blocks for each country, and then you do a second data join to create the lines. That makes sense. So D3 actually has a really nice function called nest that lets you do that pretty easily. So I have the data down here. This is the data for all these charts. So this guy, Sean Carter, who works at the New York Times, built this tool called Mr. Nester. And you can paste in data and play around with nesting functions to see how it changes the shape of your data. So actually, let me do this. So I don't know if you could actually tell from the CSV like what the structure of the data was, but but this is what it actually looks like. So it's in like, it's called like long format, or if you use reshape in R, it's, you can think of it as like melted. So every row basically only has one data point, one value, and then everything else is just sort of like an identifier. So on the top row, the only value is 90, but 90 is for Benin in 1962, and just the data source that I got it from had this classification as low income. All right, cool. So basically, when I nest this data, what I want to do is take this huge array of data and then create the blocks for each country. All right, cool. All right, so I don't know if you can see the structure here really well. So like this sort of, the top object has a key equal to the country, and then there's a values property that contains another array of all of the actual data points. And so to do that, in D3, you use this nest function, and you grab the key that you're interested in, and you use this like .entries method. You call it on your data, and then it just nests it. And then in the so let's see. I'm just going to grab this and like take it over to the editor. So basically, this is all the code that that I needed to create all of those line charts. And I don't know if you remember from like the beginning of the talk, it's really not much more code at all than I showed you initially to just like create a single line chart with 4 data points, which I think is kind of awesome. But so down here, like I grab the data in an external CSV and then use this nesting function to nest it. And then this is where I do the data join thing. So so take that nested data, I do a data join, append a bunch of divs, and then append SVGs inside of those divs. And then for each of those plots, I do another data join to create the lines inside of them. So that code I've put online. It's in that block, and when like the slides are circulated, I'll give you guys the link. Actually, I can show you the link. Well, so anyway, if you want to check out the code, you could always check out, like, I don't have too many blocks, but just bl.ocks.org and /Richie King, and you can see like the list of the ones that I do have up there. All right, cool. I'm going to turn it over for questions. So do I grab this microphone? Okay, cool. Yeah, go for it.
Can you please show an example of an article that was, kind of like production-ready article that has visualizations and things like that you publish online? like the end product?
Yeah, sure. So I showed some of these initially. So like this is on our website. There's sort of the map of the best and worst airlines. So this is all D3. The map was made with D3. All this interaction. This is all SVG. This chart down here. This is D3. Again, this World Cup thing that I showed earlier. So the New York Times. So the guy who wrote D3, Mike Bostock, he works at the New York Times and makes graphics there. So this is a drought map that he and a colleague made, and some charts showing the severity of drought over time. You can like hover and look at specific months. Yeah, so these are, oh, actually this one's really sweet. This is like directors and sort of like the stable of actors that they use for their movies. So like, you know, Wes Anderson always uses the Wilson brothers and like Jason Schwartzman, and you know, Tim Burton has like Johnny Depp in every movie. And this one, I don't know if you guys saw this one, but I think this is like one of the best graphics that's come out in a long time. But this is like the 512 possible paths to the White House during the 2012 election. So if you just focus on the battleground states, you know, like what would happen if Obama wins Florida, then like, oh, so if Obama wins Florida, it actually turns out that Romney has to win all of the other battleground states to win the election. It's like, okay, well, what if Romney wins Florida? Okay, well, so then, you know, there's still 176 ways in which Obama can win. There's 75 ways in which Romney can win. And you can kind of go through and just like play around with like, you know, these combinatorics and like, you know. So this thing I thought was amazing, just like technically kind of stunning, but also this is like exactly what you do when you're watching, you know, the like election results pour in, and you're like, okay, all right, like the results have been announced in Florida, and like Romney won. So like, what does that mean? How many other states would Romney have to win, or how many states would Obama have to win to actually win the election? And like this tool just makes it like possible to actually do that. Cool. Another question? Yeah.
So I inherited some D3 code that a consultant wrote, and we put into production, and he left, and now we have his code. And it's difficult to maintain in production. It makes sense, but it's all very ad hoc, meaning that everything that was made for a specific purpose. Now we need to turn out, let's say, 10 more charts like this every month.
Yeah.
And I'm wondering if you have any advice for how to sort of productionalize the production of D3 code of these charts, or what experience you've had with that.
Yeah, so I mean, you know, I think that you can do things that are super, super customized in D3, but it's also possible to do things that are pretty generic. I'll show you a where's this thing? So a colleague of mine at Quartz built this chart making tool for people in the Quartz newsroom to use to make charts. And so like you can like paste in data, and the values will change, and then you can, you know, like you can whatever, like spit out an image. So if you go to the Quartz website, like they have countless charts that have just been made with this chart building tool, and it's you know, so like this was spit out of Chart Builder, and yeah, Chart Builder. So I would recommend, like, you know, that's a tool that was built to create a bunch of similar looking charts in D3. So there's another one. And it creates charts over and over again. So yeah, I would definitely recommend like checking out that code if you want like an example of how to do it. But I think you can sort of make it as generic as you want to. It sounds like the person who gave you his code had just made it like way too specific. Yeah.
At a high level, how would you rate D3 compared to iOS or Android native visualizations?
iOS or Android.
If you have any experience there, or just people hearing.
Yeah, I actually don't even know what are iOS and Android native visualizations. Oh, like just like for apps or? I don't know. I mean, I've only ever done web development. I've never worked on an app before, so I can't really compare.
So it seems like D3 can do pretty much anything. But
Yeah.
How do you approach it if you don't really know how you want to display your data? Like, what do you ask yourself is what is the best way to display this to my users?
Yeah, that's a great question. So, like whenever you're doing data visualization, it's super important to do like prototyping just to see if something will work. And that's, for more basic chart forms, like that's when I would just use Excel or like ggplot in R or like actual charting tools just to get a quick look at the data and see if like it makes sense to display it in that form. For things that are a little more complicated, like I'll try to do some sketching, like even by hand sometimes, and or using a tool like Illustrator. People who are like really, really awesome at D3, like it's that guy Sean Carter at the New York Times, like he does all of his prototyping in D3, which to me is like crazy, but he's super fast at using it, so totally makes sense. But yeah, like using basic tools like Excel can be super valuable for that. Cool, yeah?
How do you approach doing the zoom kind of effect? Is it deeply nesting the data and loading it all up front, or I'm just curious about how you achieve that kind of effect?
Yeah, so that's a really good question. So the question was like, how do you actually achieve a zoom effect in D3? I think the fastest way to do it is you are actually sort of you have a large data set, but you're kind of creating the visualizations on the fly as you're zooming, and so you're sort of pruning the data to just like give you the slice that you want, and kind of update it as you're zooming. That's I think that's like the fastest way to do it. Yeah. Cool. Any other questions? All right. Oh, yeah.